Alright, we're going to work on some congruence proofs. This is a triangle congruence worksheet. I'm going to show you what it looks like real quick. Okay, set this on top. Basically, you should have already done this, and what we're going to do is I'm just going to go over all these proofs. I'm not sure if I can fit it in these boxes, but I will try, I guess. It looks better if I do. So let's go ahead and go through this. And I have a previous video where I go over all of the tools that we will use, and I might bring my toolbox back in here to look at stuff. Okay, so before I even start anything, I'm going to plan out my proof. And so let's see what we can do here. Okay, so I see perpendicular, perpendicular, and congruent. Okay, again, looking at my toolbox, perpendicular right here is going to create 1 to 4 right angles. And so with the right angle, we could create a right triangle, or with the right angle, I can use right angle congruency theorem to create 2 congruent angles. Okay, so we'll see what we need to do on that. Okay, this particular proof, they label the stuff that we are going to have to do already. So sometimes that's confusing. So I'm going to mark on top of it to see what we got. BC equals DC. Okay, and it looks to me like, okay, so this, eventually we're going to create a right angle here and a right angle here, and I'm going to pull this back again, vertical angle here. Looks like that X, right? So we're going to use that vertical angle theory to prove 2 things. So I'm going to mark that. So that's what we're going to do with our proof. So I'm going to have to do all 3 of these things. One of them is given. This one is given. That's easy. Okay, so my thought is I'm going to end up with a probably an angle side angle. That is my thought. So let's go ahead and go through this. Excuse me. Okay, of course we're going to have to go ahead and write our given. Okay, and I'm probably not going to be able to write it on the same line, and that is okay. Segment at BD, perpendicular AB, okay, and then we're going to have BC, it's congruent to DC. Make sure they're segments. Okay, and this is going to be given. Okay, that's easy. And I'm going to switch colors so we can kind of see my thing. So already in my given, I got a side. Check that off. So let's go ahead and start right here with the parallel lines. Okay, I'm going to say ABC. Okay, angle ABC and angle EDC are right angles. And that is the definition of perpendicular. Okay. That didn't prove my stuff yet. Now I'm going to say ABC and nope, not and. ABC is congruent to angle EDC. And that is the right angle congruence theorem. Okay. Moving on. Oh, I got to check it off. I got an angle there. And then the last thing, I wish I could do angle C equals angle C, but it's technically going to have to be like angle ACB is congruent to angle ECB. Because of the vertical angle theorem. Okay, so now I got AA. Okay, I didn't point out earlier, but I'm not supposed to prove that triangles are equal. I'm supposed to prove that A is congruent to angle E. Okay, I'm supposed to prove this guy is congruent to this guy. Okay, but I'm still going to do this. Triangle A, B, C is congruent to triangle E, D, C. Oops, forgot the little triangle in there. And that is because of ASA. Okay, so I still do the same thing that I do. It just gives me one step further. And so I'm going to finish off with angle A is congruent to angle E. And that's because of corresponding parts of congruent triangles are congruent. So the CPCTC theorem. And that concludes that proof. This is a good one. We got what? The given 1, 2, 3, 4, and 5. This is a pretty good one. If you got this one right, you're in great shape. Let's move on to number 2. Okay, number 2. I'm going to go over this one, and we're going to come up with our thoughts here. And this one looks easier to me, and let's see why. Well, looking at the given, I'm given a side, and they marked it for me, BC, and I'm given another side. Okay, already I think that I have two sides. They only give me two sides, and I'm noticing that it has this shape here, vertical angle theorem shape. So I'm going to assume that we're going to do this, and this would be side, angle, side, side, angle, side. So that's what I'm going to try to do. So I'm going to start with my given here. All right, BC is congruent to DC, and AC is congruent to EC. Given. I like a given like this because it makes my life easier, where already I have a side and I have a side. All I have to do is come up with an angle, and I'm going to come up with that angle right now. Angle BCA is congruent. BCA is congruent to angle DCE, and that's because of vertical angle theorem. Got it. Triangle ABC congruent to triangle EDC, and that's the side angle side theorem. Okay, moving on to 3. And of course, if I'm going too fast for you, this is a video, so stop it, pause it, rewind it, use it like I'm stuck. Now I've given you a clue. Stop it, see if you can get it finished, because the test is coming. I think today you're working on the last bit of proofs before the test. We got one section after that, and so we'll be preparing for that. All right, let's go ahead and again, they marked it up. They won't always get to mark it up. I prefer they not, but some people do. So YA is congruent to, okay, angle, okay, and again, I got that shape. It looks like that vertical angle shape. So I think this is going to be an ASA shape. That side's in between the two angles. Okay, great. Now I am proving two sides. So I'm trying to prove AZ is congruent to AC. Okay. So that shouldn't be a big deal. So let's go ahead and look at this and see what we got going. Okay, let's just write our given here. YA congruent BA, angle B congruent to angle Y. Given. Okay, just from the given, I got an angle, I got a side. Okay, let's do this. Y. I'm going to do this YAZ, angle YAZ is congruent to, so YAZ, so that's congruent to BAC. And that is, again, vertical angle theorem. We use that a lot. Anytime they're touching like that. Okay, moving on. I guess I proved 2 triangles already, because that's another angle. So triangle, let's just call it AZY. AZY is congruent to ACB. I forgot my little triangle, ACB. And that is because of ASA. And of course, I've told you earlier, if we're proving these sides, it's easy. You just got to remember the one theorem. And that one theorem is the corresponding parts of congruent triangles is congruent theorem. Okay, we're moving right along. And let's see how bad the backside is. It's not too bad. I think I have another copy that I set down somewhere, so we can use that one instead, so it's be clean and not see all that writing. But of course, I recommend doing a lot of this in pencil, so you can erase or whatnot. It just shows up better on camera with colored pens. Okay, so here we go. Going too fast for the camera. All right. So I'm going to look at this real quick before I start writing it. Okay, so I got parallel lines. Let's see what parallel lines can do for us. Okay. Parallel lines, right down here, creates 2 congruent angles with one of these theorems. Okay. So we're going to create angles. So this is going to be an angle. That's going to be a side for sure. And then, I think it looks a lot like this. We're going to create 2 equal sides with the reflexive property, because it looks like that. Okay? So, I think we're going to have a side also with that reflexive property. So, it's got to be in this order, because if it is in this order, that is not one that works. Okay? The only way we could do this order is if it has a right angle, and then we wouldn't call it this, we'd call it HL, or hypotenuse leg. So just don't do that. So just know that it has to be in this order. So I'm going to mark up my shape here. It's going to give me this side given, sure. We're going to use this reflexive. And then it has to be this angle and this angle, because we have to be side angle side. If I use any other angle, it's not going to be in between the two. Okay? So that is kind of our destination there. So let's go ahead and do this thing. WX parallel YZ. WX congruent YZ. That's my given. Okay. That's easy. Never get the first step wrong. It's too easy. So I did have a side here. Now I need to come up with, well, I'm going to come up with my other side because it's easy. ZX is congruent to ZX. And that is going to be the reflexive property. Okay, piece of cake. Now let's go ahead and look at these angles. It has to be this angle, and so let's write these outright. So I'm going to start here. ZXW angle is congruent to CXW. So let's do this XZY. And that is because they're inside the parallel lines, so it's going to be alternate. Interior angle theorem. And there we do. That's it. That comes up with my angle, and so I finish it out. Triangle WXZ is congruent to triangle YZX, side angle side. Okay, so far what we have here. We've done angle, side, angle, side, angle, side, angle, side, angle. Okay. We're going to keep going on this stuff and just kind of get it going. Okay. This will be kind of a long video, but some people might need me to go through all 7, so I'll do that. All right, let's look at this strategy here. We got an angle, midpoint. Let's see what midpoint is going to do. Midpoint is going to create 2 equal sides, okay? 2 equal sides. Okay. And let's see here. It looks like L is the midpoint of KM, so that's the midpoint right there. So that's going to create this, going to be equal to this. And it gave me these angles, so, and it looks like that vertical angle again. So I'm going to think it's angle, side, angle. All right, we're going to write the given. And I think I've demonstrated the given. Well, let's just keep doing it. Let's do it right. Okay, congruent to angle M. L is midpoint of KM. That's my given. Okay, my given gives me an angle right here. If we can see it, I'm crooked. Okay, let's move on. Let's go ahead and do the side here. So I'm going to say that MK, or ML, is congruent to LK. And that's going to be the definition of the midpoint. At least in this book, that's what it would be. Okay, and then move on to, so I got a side here, and then move on to the angle. I'm going to call it angle MLP is congruent to KLJ. And that is going to be vertical angle theorem. And I got my angle. And I'm going to just close this out. Triangle JKL is congruent to triangle PMLASA. All right, moving on. Okay. All right. Hopefully this lag does not come out in the video, but it might. I'll need to clear up some stuff after this video. All right. B and D are right angles. Okay. We're going to have to use some theorems here to make them equal, but it does tell me they're right angles. AE bisects BD. Let's see what bisects does. So that's a segment bisector, creates 2 congruent sides. Move that pen. Segment bisector creates 2 congruent sides, okay. And so that's going to be, okay, angle, and then we got side. Okay, and so which side is it going to be? AE bisects BD, so it's going to be this and this, because AE cuts BD in half. Okay, and let's see here. I bet you we're going to go vertical again. So that's an ASA. Okay, right angles don't automatically mean HL. It just depends on what information they give you. Since they gave us 2 angles, we're not going to use HL. So B and angle D are right angles. Okay, I'm going to do this in a slightly different style. Some people do it in this style. This is a given. And what does that mean? What that means is angle B is congruent to angle D. And that is because of the right angle congruence theorem. Okay. This time, you don't have to, but this time I split the given because this gives me information. So that gave me an angle. And now I'm going to do the other given. AE bisects BD. That's a given. What does that mean? That means that BC is congruent to CD. And that's the definition of segment bisector. Okay. So that gives me a side. And now we can do angle BCA is congruent to angle DCE. And that is vertical angle theorem. Okay, and of course I did this with the split given just to give a different style. Some people like to start with one thing and finish. Start with one thing, and the second thing and finish. Do the third thing, which is that other angle. And then of course we can finish right here and say that triangle ABC is congruent to triangle EDC ASA. All right, last one on this worksheet. And again, I'm doing this whole worksheet because this one has a lot of thinking where you have to figure out. You can't just you got to figure out the ending. All right. JM bisects angle J. Okay. Angle bisector. Angle bisector creates two congruent angles. Okay. So that's going to be an angle. So that's going to create an angle. JM is perpendicular to KL. Well, we know what that's going to do. That's going to create an angle. We already did that one before today. So we're going to have to do some stuff with that. And looking at the shape, it looks like the two triangles share a side. So that's going to be reflexive property. Okay. So basically, we're going to make this equal to this because of the bisecting. We're going to make this equal to itself. And of course, the right angles right here are going to be because of that perpendicular line. Okay. So let's get that done. It looks like this is an angle side angle again. So we have a side angle sides, angle side angles a lot here. I wish there was more on this particular one, more different endings, but that's what today's work is. Today's work will have more different endings. I like this because of all the different ways that we can translate things to get these things. Okay, so let's start with, and I'll do a split one again, just in case people like that way. JM bisects angle J, given. That's going to create KJM is congruent to LJM. And that is because of the definition of angle bisectors. I guess you don't need an S. All right. So there we go. You got an angle. Let's do the next given. JM is perpendicular to KL, given. All right. That means JMK, angle, I should have said that, and angle, JML, are right angles. That is the definition of perpendicular. Okay, I'm going to have an add-on here because we're going to run out of room, but that's okay. Let's get it all in there. Nope, other way. That's the definition, and we're going to have to write JMK is congruent to angle JML, and that is because the definition created the right angles, and that's because of the right angle congruency theorem, which means all right angles are congruent. Okay, so now we have to change. Blue on blue doesn't work very well, so I'm out of room on this one. This one just takes some room. So what did we just prove here? We got another angle, and now we need a side, JM. So JM is congruent to JM, and that is the reflexive property. Ran out of room there, and so we can finish it out because we got our side here. We can finish it out. Triangle JMK is congruent to angle JML, and that is because of, it should be over here, but that is because of the ASA. All right, so that's it. I'm going to end this video. If you have any questions, you can email or whatnot. But we will have more videos tomorrow going over the proofs, and then we will also have the new lesson tomorrow. So see ya.